Hello. In this lesson, we look at the topic is something called measures of central tendency. The goal is to be able to get some data set and describe what the typical value is. So we'll start with an example, a context to kind of hang our hat on. So let's say a realtor in San Francisco is doing some market analysis. The prices in thousands of dollars for a sample of houses in the same neighborhood as the one she is selling are shown. What is the cost of a typical house? So there's 872,000, 432,000, dot, 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 dot. Well, what do they mean by typical here? Ideas? Well, there's a variety of ways that you can describe typical. And we call the variety of ways that you can describe typical are measures of central tendency, where the central part of our data set tend to be. A value that represents a typical or central entry of a data set is what we mean by a measure of central tendency. And the most common measures of central tendency are the mean, median, and mode. Items you've probably heard before. The mean is another name for the average. How do you find the average? It's the sum of all the data entries divided by the number of entries. You can write this using sigma notation. It's using the Greek S sigma. It stands for sum. So this right here is a set of directions. You'll just see it in textbooks, mathematical textbooks. It's used in statistics and calc and a variety of other aspects. So this just means sum all the x's. Add up all of the or all the data entries in the data set. So if I want to find the mean, I sum all of the pieces and divide by the total. You'll see the population mean is denoted by the Greek letter mu. It's the Greek M. It does look like a U to us, but it stands for mean. That's the population mean. That's the average of all of the items that we're concerned about. Well, we can't study usually the population, so we do a sample. When I take a sample, again, I add up all the pieces, but this time I'm dividing by small n. Small n is the number in the sample, whereas large N is the number in the population. I usually can't determine the population mean, so I take a sample and we denote that with an X with a bar over it. So in statistics, it's common if there's a bar over it, it implies average. In this case, it's going to be the sample mean, the average of the sample. Okay? The median is another value that you can use to determine the central point. The median is the value that lies in the middle of the data when the data is ordered. The median measures the center of an ordered data set by dividing it into two equal parts. If the data set has an odd number of entries, then the median is the middle data entry. It's actually a data point in your data set. However, if the data set has an even number of entries, then the median is going to be the average of the two middle entries because there is no way to evenly divide. It's when there are an even number of entries without using a point that is not in your data set. The mode is another way of finding the typical value, and that is simply the value in your data set that occurs with the greatest frequency, the most often. If no entry is repeated, the data set has no mode. If two entries occur with the same greatest frequency, each entry is a mode. So you could say it would be bimodal. If there were three, it would be trimodal. Those are the three measures of central tendency. So we'll use our small data set from our San Francisco market analysis to determine what is the mean, median, and mode. So the data ordered from smallest to greatest, and the mean would be of the data set, so it'd be X with a bar over it because it's a sample of it's the sample average. I add up all the pieces, so sum all the X's and divide by the number. There are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this is going to be 388 plus 397 plus 397 plus 427 plus 432 plus 782 plus 872, all divided by 7. There are 7 entries. Then you grab your calculator. Then you're just number crunching. 388 plus 397 plus 397 plus 427 plus 432 plus the 782, large jump there, 872, divided by 7. Find the average to be 527.5. 0.9. And these were in thousands. Dollars and thousands. The median, well, because I have an odd amount, I will actually be able to pick the middle point and it will split my data set. And that is going to be this point because there are 1, 2, 3 to the left, 1, 2, 3 to the right. If there were an even number, there'd be 2 middle points, I'd have to average them. But in this case, there are not. So the median is simply $427,000. The mode is the one that occurs with the greatest frequency, and that are these two. There are two $397,000. So 397,000 would be the mode. That's the one that occurred the most often. So those would be the 3 measures of central tendency for this data set. Just to show an example of one where you might have an even number, show what that would look like. If the house priced at $432,000 is no longer available, what is the new median price? Well, what we do now, because there's an even, there are 2 middle values, these ones right here, we would simply average the 2. And when you do that, you find then the new median would be $412,000, just to show an explicit example of what if you have an even number of data entries. You average the 2 middle ones to get your new median. I'm going to give you a chance to try. So the following are the prices of 11 houses in the Helena area in thousands of dollars. Is shown below. Find the mean, median, and mode of this data set. So pause the video now, give yourself a chance to try, and then come back and see how you did. Okay. Answers are as follows. The mean you should have calculated would have been $371,400. The median is $250. The mode is $225. In the prior example that you just did, which measure of central tendency seemed like a non-typical value? So if I go back and look at these, like, well, these two are kind of closely linked. This one is noticeably higher, though. So the advantage of using the mean is that the mean is a reliable measure because it takes into account every data point in the data set. There is a large disadvantage, though, and that is because it can be greatly affected by outliers. An outlier is a data entry that is far removed from the other entries in the data set. For data sets that have outliers, this is important. It is best to use the median. So if I go back and look at this value right here, that's a $1.5 million house. It is greatly going to affect the mean of these houses where they seem to typically fall around $250,000, $250,000. And I can see that increased the mean, by $120,000. So it would not be best to use the mean as the typical value in this case because of the outlier. It would be best to report the median. So the median would be best to use in any case that there is an outlier, high or low. The example we're going to look at here is how do I calculate when items have been used over a class level, a range of values. So the situation is the following. A company hires you to track the number of minutes visitors spend on their social media website during a recent session. So when they visit the website, how long do they stay there? What was the average number of minutes for each visitor? Well, the problem with the way that the data was obtained is that it was done using intervals. So for example, just to read the data set, this first one, there were 6 visitors that spent between 7 and 18 minutes before they left. So how do I determine an average when some might have spent 8 minutes and others might have spent 14? So what we do is we calculate the midpoint for each of the class levels. So simply add the items together, divide by 2. So 7 plus 18 divided by 2 leaves me 12.5. Then I do the same for all of the class levels. Now I can start to calculate the average. How am I going to do that? Well, I'm going to do this for each of the class levels. So I see there were 6 people that spent an average of 12.5 minutes on the website. So I can then do 6 times 12.5 to see how many minutes those 6 people spent. So 6 times 12.5 means those 6 people spent 75 minutes on the website. Then on the next level, there were 10 people who spent an average, or a midpoint, I don't know if it's an average necessarily, of 24.5 minutes. So 10 people at 24.5 tells me that that would be 245 minutes spent by that group. So what am I doing? I'm simply just multiplying these two values because it's a number of visitors and their midpoint value for how many minutes that they spent. So this one would be simply 13 times 36.5 tells me that group of people spent 474.5 minutes on the website. 8 people at 48.5 minutes, so 8 times 48.5 tells me that group spent 388 minutes on the website. There were 5 people at 60.5 minutes, which is 302.5 minutes on the website. I'm going to run out of color, so I'm going to have to cycle back through. There were 6 people at 72.5 minutes, so 6 times 72.5 tells me those 6 people spent 435 minutes on the website. And then there were 2 people who spent a long time on the website, 84.5 minutes, so 84.5 times a 2 is the 169 minutes those people spent. And now I have all of the minutes spent on the website. 75, 245, 47, 474.5, 388. What I'm going to do is I'm going to take these values and I'm going to add them up. And that'll give me the sum number of minutes. So 75 plus 245 plus 474.5 plus 388 plus 302.5 plus 435 plus 169 will tell me how many minutes all of these people spent on the website, and then all I need to do is divide by the number of people. There were 6, 10, 13, so 6 plus 10 plus 13 plus 8 plus 5 plus 6 plus 2. There were 50 people, or 50 visitors. So I need to add all of this up. So 75 plus 245, 474.5, plus 388, plus 302.5, plus 435, plus 169, leaves me at 2,089 minutes spent by 50 people. If I take that divided by 50, I get that the average person spent 41.8 minutes on the website. So I need to take the midpoint and multiply by how many were at that level. That is how I can find it for a class level situation. In terms of graphing and what role that plays on the measures of central tendency, it can induce something called, there can be skewed distributions or what we call symmetric distributions. So skewed distributions are when they are not symmetric. So a negatively skewed distribution is when the majority of the data are to the right, there's a tail on the left. A symmetric distribution is when obviously it's symmetric, the right and left tails are about equal. A positively skewed distribution is when the majority of the data are on the left, when the high values on the right are actually going to induce some skewness. So why are they called that? You also hear that they're called left skewed and right skewed. So we describe them based on where the tail is. And the reason why is because the tail, it is acting kind of like some outliers, and they're going to affect the mean. So if I look here, the majority of the data are located right here. But these low values are acting as outliers, and they're going to pull the mean down. So that's why the mean is going to occur the furthest to the left in this case, because it is the most greatly affected of the 3. The mode is where the peak is. The median is in between. We call it left skewed because these lower left values are skewing the mean, or negatively skewed because it's towards the negative direction. On the opposite side, if I have some high values on the right side, the right tail, positive values, some high positive values, they're going to pull the mean upward, just like our example with the housing prices in Helena. We call this a right skewed distribution or a positively skewed distribution because the mean is higher based on the skewness that is occurring within the distribution. So we will use that to describe data in the future. The mode is always at the peak, the mean is always the closest toward the tail, and the median is always in between. A quick example. So in this picture, I'd like to describe the type of skewness, state the mean, median, and mode, and finally share if it would be better to use the mean or the median. In this case, the type of skewness is there's positive or right skewness. These values, if I drew in the picture of the distribution, it looks something like that. So this is some, you would say, positive or right skewness. It is not symmetric. Now I have 3 options, A, B, or C for the mean. The mean is going to be the one that's the most greatly affected because there's some high positive values. The mean will be the one that's closest to that, so the mean is going to be C. It's the one that's most greatly affected by that skewness. The mode is where the peak is, and I can see the mode is at A, and the median is between, so this is CBA. Because there is skewness, the best measure to report would be the median. It's always probably best to honestly report all three, just, more data is always better, but the median is going to be the one that's probably most representative of the typical value because of the skewness going on. And then last part, I'm going to give you a chance to try. See an example of similar to what I did with the number of minutes average that people were on a website. You can also use that in order to calculate your grade when there's a weighting. So you are taking a class in which your grade is determined from 5 sources shown below. Calculate your final score. This is called a weighted average, as it is found the same way as the average from our online visitors example. So you took a test, got an 86 on it, and that's 50% of your grade. The midterm was you got a 96, and that's 15% of your grade. The final exam, you got an 82, and that's 20% of your grade. The computer lab, you got a 98, and that's 10% of your grade. And the homework, you got 100 on, and that is 5% of your grade. What was your average score, which is then going to act as your final score? Pause video now, come back after you've given yourself a chance to try. Okay, what you would do is you would multiply each of these pieces. Multiply the score by the weights for each of the pieces, and then add up all of these. In this case, you get 88.6, and then you divide by the total weights. Well, the total weights in this case is 1. So what it means is your weighted score for the course would be an 88.6. And that's how you calculate your final grade in a situation where you're in a course that has weighted scores. That is it. Thank you very much. Have a good day and stay curious.